breaking the wall of our sun's mysteries. How connecting solar observations to space probes reveals new insights. Miho Janvier, European Space Agency.
On November the 9th, 1989, I was living in Helsinki. No matter the walls, physical or mental, that we erect between us.
Good evening. It's been mostly cloudy today in Berlin, with a cool breeze and a high around 7 degrees Celsius. So keep that jacket handy if you're heading out. Now, turning our eyes beyond the clouds, space weather is looking fairly calm after a few days of disruption. The sun has been showing a few bright active regions over the past few days. Solar wind speeds were quite strong on Friday, with chances of auroras. But today, the skies above Earth seem relatively quiet, with no disruptions expected for satellites or GPS. And for our aurora fans, a small coronal hole could bring a touch of northern lights to higher latitudes tomorrow night. So keep looking up. The show might just be in the sky.
When you think about weather, you probably think about rain and clouds. Maybe images of hurricanes and storms come into your mind. But did you know that space also has its own weather? Space weather corresponds to the changes in the space environment, such as in the solar system, due to the sun's variability. This is a real footage of the sun at the center and the surroundings of the sun. And each of the puffs that you see are actual solar storms. These are happening above our heads in the sky. Now you may think this is way too above our heads in the sky. It doesn't really matter what happens in there. What I want to know, and what my grandparents always ask me, is where's the sun when it's raining here on Earth? But it does matter to you, and it does matter to me. Because space weather has a lot of impacts, especially on our technologies. It can impact satellite communication, GPS. It can also impact civil aviation, astronauts, and also electricity grids here on Earth. It's not only bad things, of course. We also have absolutely beautiful celestial displays in the shape of northern and southern lights. If you ever get the chance to see some, I highly recommend to do that. But let's go back to a real event. This is the Iberian Peninsula back in April of this year. A blackout, electricity blackout everywhere in Portugal and Spain. Okay, that is not sun-related, but this is just an example that I want to show you, because for an event that lasted less than 24 hours, the estimated economical cost of this electricity blackout is 1.3 billion euros. Imagine this at a much global scale, over a lot of different countries covering the globe. This is such an event, of course, that governments around the world have started preparing in the form, for example, of space weather prediction centers. In the word of a US administrator, a former US administrator, the keywords are to predict and to prepare. Of course, I'm not going to talk so much about space weather, because what I want to talk to you about is what we have discovered about the sun that helps us with these predictions. I am a solar and space physicist, which means that my keen interest is understanding first and foremost our star. So back to basics, I'm going to start with the light that comes from the sun. The light that comes from the sun, like any of the stars of the universe, is very varied. But we, as humans, with our own human eyes, we only perceive a small section of this light that comes from stars, what we call the visible light. This is the sun in visible light. It's probably similar to the drawings you used to do when you were little, this yellow, orangey ball, where, we have a smooth surface, sometimes with a few spots, what we call sunspots. There's not much happening. But remember, this is only one part of the full story. Stars And the sun emits other types of light, what we call X-rays, or UVs, or infrared, even radio waves, are part of the light that comes from stars. And this is our star, the sun, in ultraviolet light. A complete different landscape to what we have seen before. Now, not only do we see bright regions, we also see dimmer regions. And this is constantly evolving over time. I'm going to make an analogy here, and I'm going to present our planet Earth and then the sun on the side. Both are globes and both have poles. We can define the regions at the poles. And both have regions that are much quieter. A bit like on Earth, you may have regions of the globe where you don't have a lot of natural events, maybe not so many earthquakes or volcanoes. In terms of weather, it's not really the place where you would find hurricanes. And then you also have places on Earth where you have regions that are active in terms of natural disasters, earthquakes, volcanoes, hurricanes. And the same happens for the sun. But it doesn't happen, like on Earth, in the sense that these regions are constantly changing over time. I'm talking days, even minutes. Things are changing and very variable in the sun. I'm going to stop talking just for maybe less than a minute to let you appreciate all the footage that we now have of the sun, and that will hopefully let you a taste of what it means when I say that the sun atmosphere is very variable. So please enjoy. So now we have some music, but it's okay if we don't. All the things that you see here in the sun's atmosphere are evolving at a scale of a few minutes to a few hours. And a key element of these dynamics is actually the sun's magnetic field. The sun's magnetic field is omnipresent. It is absolutely everywhere, and it will shape the sun's material. And this magnetic field, again, is evolving over quite a few years. Not as long as the Earth, I'm talking around 10 to 13 years, in what we call the solar cycle. In this image, you have the sun in extreme ultraviolet light, the orangey bit that is quite flurry, and the one on the right side is the visible light. And you can see that over time, you've got the years. Over time, we've got more and more sunspots appearing on the surface of the sun. But what is interesting is that all these active regions, the bright regions of the sun, are also evolving over time. Again, over the scale of 10 to 13 years. And this will lead to explosions or solar storms as time goes by. So we've got a nice video here where we're zoomed on the sun at the beginning, and we see this seed of a solar storm. And then as time goes by, you see this storm that is expanding and becoming much bigger as time goes by. This is what is a solar storm. Literally some solar material from the sun that is escaping the sun and growing until it reaches, if you have a planet on its trajectory, planets of the solar system. And that brings us to a lot of questions, right? I talked about the magnetic field. How is the magnetic field generated? Can we predict active regions? Can we predict when these active regions are going to explode over time? To answer these questions, 5 years ago, we launched in space a spacecraft called Solar Orbiter, an international collaboration between the European Space Agency and NASA. I like to call it the Swiss Army knife of our community because it transports on board a lot of telescopes that are looking at the sun and also sensors that are monitoring the space environment of the spacecraft. It's literally looking at the sources. For example, if you were on a boat looking at the water falling in the Niagara Falls and scooping the water once it reaches your boat. We can do that. We are ingenious to do that. And it has really changed my life. This is a picture of me in front of the spacecraft with this cover that we call the lab coats in order to be in a clean environment. And there was just a few weeks before it was sent actually from Germany, where the last tests were done, all the way to Cape Canaveral in Florida. February 2020. We gathered family, colleagues, friends. This is an hour before launch. You're going to see two videos, one where we see the rockets at the center, and this is the view that we saw us on the benches. I think the sound is not going to work again, but you have the countdown. Maybe I can talk to you that we were completely white-faced, holding hands. Some of us were screaming, hooray! Is this normal? I hope there's no explosion. Actually, we had an extremely beautiful launch. Our spacecraft was put in a really nice trajectory, and for the next 5 years, I got to work on the mission. Now, mind you, that was in February 2020. We were very lucky, because a few weeks later, we were all locked down in our house. This is the trajectory of, so just a visual impression of the orbit of Solar Orbiter in white. And what I want to show you here is that the orbit of Solar Orbiter, as time goes by, is tilted, which means that we're getting out of the planes of the orbit of Earth. So we have now a new view, and a new view that humanity has never had before of the poles of the sun. Remember I talked about the poles of Earth? We're now looking at the poles of the sun. So what have we learned with Solar Orbiter? Many things. Unfortunately, I don't have the time to go through everything. But the fact that we're getting closer to the sun with our telescopes means that we can see in many more details the atmosphere of the sun. This is the sun, the full sun, and you can see the amount of details that we see now. This is a video. And maybe one thing that I can hint is that those tiny little brightenings that you see, we think are mini explosions, similar to the big explosions that are happening. And maybe they hold the key of why the sun's atmosphere is so extremely hot. Because Solar Orbiter sometimes goes behind the sun, as seen from Earth, we can also follow active regions that we cannot see from Earth. And that's the case for the active region that gave us really nice auroral activity last year. So you can see it with the white circle. We're following it from Earth, and then it passes behind, Solar Orbiter catches it, and it gives us, again, a missing puzzle of the evolution of these active regions, allowing us to constrain our modeling. I searched and I found that indeed in Berlin, you also had the chance to look at the Northern Lights. So who here, by the raise of hands, saw any of these auroral activity last year? There was one in May and one in October. So I see one hand, 3 hands. Not that many. Next time, put an app on your phone. We have now auroral alerts that can tell you, but generally they happen at 2 a.m. when everyone is deep asleep, and they send you an announcement saying, like, go outside and watch some auroras. We have also seen the poles, as I said. So this used to be the grazing view that we had of the poles, where there was a hint of quite some activity going on. Now we have this view, so this is a view from another spacecraft that we have, but just to show you the difference, this is the view from us, or the view from the original view that we had, and this is going to change to the Solar Orbiter view, where now we're looking at the poles of the sun in a high amount of details. And what it is showing us is that the poles are also the regions where we find strong magnetic fields, a magnetic field that is changing over time, and that may hold the key of the solar cycle. So watch this space. I want to finish with 2 beautiful images. One is an artist's view of the Earth and the sun, and the message that I want you to keep is that we live in the neighborhood of an active star. Good. Don't look at the sun with your directly, even with your sunglasses. And the last one, yeah, actually, that's good. And the last one is this beautiful image that we get from the James Webb Space Telescope. That's really good, actually. But it's night, in that time now. So now we can turn to astronomy. And this image actually shows that all these bright points are stars where we find exoplanets orbiting around them. And so a question for you is, are you going to be with me on this journey to understand the sun's mysteries and also the stars' mysteries and whether there is life on the planets orbiting those active stars out there. Thank you so much.